Hello, I'm your teacher, Ma'am Bing. Welcome to my class.
Our lesson for today is about element, compound, and mixture. These are the following objectives. Define element, compound, and mixture. Identify whether the given sample is an element, a compound, or a mixture. Differentiate element, compound, and mixture from one another. Overview of the lesson. You have learned that matter is anything that has mass and occupies space. And it has two classifications, substance and mixture. When we say substance, it has definite properties and proportion and always homogeneous in nature, while mixture, it is a physical combination of two or more substances. Physical means do not alter the nature of the substance, they simply change in form. Substance has two kinds, element and compound. When we say element, it is made up of only one kind of atom, while compound is a chemical combination of two or more elements. Chemical means change the properties of the substance. Observe this activity. Based on this activity, what do you think is the basis of classifying these objects into element, compound, and mixture? These are names of elements found in the periodic table. These are not included in the periodic table of elements, as you can see two or more elements combined. These are also not included in the periodic table of elements. These are combination of two or more compounds. Let us learn more about element, compound, and mixture.
Distinguish between mixture and compound. Using a spatula, take a small quantity of sulfur powder and transfer it into a beaker. Add a small quantity of iron fillings into the same beaker using a spatula. Stir the contents of the beaker using a glass rod and label this mixture as A. Take a china dish and using a spatula transfer a small quantity of the mixture into it. Heat the contents in the china dish strongly by placing it on a wire gauze that is placed over a burner. Stir the contents constantly till a black mass, that is compound of sulfur and iron, is formed. Cool and transfer the contents into a mortar and powder this using a pestle. Then transfer the powdered contents into another beaker using a spatula and label it Black Mass B. Test on the basis of appearance. Take a small quantity of mixture A and black mass B in two different watch glasses. Mix the mixture A in the watch glass using a glass rod. You will see yellow powder in which some iron fillings are visible. Then mix the black mass B in the watch glass using a glass rod. No iron fillings are visible in the black mass B. Thus we infer that a mixture is heterogenic and compound homogeneous in nature. Behavior towards a magnet. Place a small quantity of mixture A in a watch glass and a small quantity of black mass B in another watch glass. Show a magnet over the watch glass in which mixture A is taken. Iron fillings cling to the magnet since iron retains its properties. Show the magnet over black mass B. No particles attach to the magnet because iron loses its magnetic properties on forming a compound.
Try to analyze this. Different ways of separating mixtures and compounds.
Hey everybody, this is Mr. Millings, and today we're going to learn about separation techniques. In an earlier video, we discussed how all matter can be classified into two main categories, pure substances and mixtures. And we said that if you have a mixture and you wanted to separate the components of that mixture, then a physical process would have to take place. Some sort of physical process would have to take place in order to separate the components of that mixture. And we said for pure substances like a compound, like water, a chemical process is going to have to take place to separate the hydrogens from the oxygen in a water molecule, which is a pure substance, right? So mixtures can be separated through a physical process, while pure substances can be separated through a chemical process. And today in this little video here, we're going to talk about 6 different ways that we can separate a mixture, and then we're going to talk about electrolysis. So let's jump right in and take a look.
Centrifugation is the process of separating a mixture based on the densities of the particles in that mixture. Chromatography is the separation of the mixture in which the components move at different rates, usually used when separating the components of an ink or dye. Filtration, the mechanical or physical separation of a mixture based on the size of the particles in that mixture. Distillation is a process of separating a mixture of 2 or more liquids based on the boiling points of the liquids in the mixture. Decantation, the careful pouring off of a liquid from a mixture containing both a liquid and a solid. Magnetic separation, a process in which magnetically susceptible material is extracted from a mixture using a magnet. This separation technique can be useful in mining iron as it is attracted by a magnet. Electrolysis, the chemical separation of the hydrogen atoms from the oxygen atom in a water molecule. Smelting, extraction of metal from its ore involving heating and melting.
Hey guys, this is Jason with Mount Baker Mining and Metals, and today I wanted to do another smelting experiment here. I've got some cutting. So I've just taken the concentrates out of the pan, washed them into a cast iron frying pan, and now we're going to put them over some heat, get them up to probably somewhere around 800 to 1000 degrees Fahrenheit. I've got a little propane injector there. There's the tank. It's just a little propane burner. Got some KO wool wrapped into a little cylinder there with a top on it. And here's our little scale. We've got our oxides now, our roasted sulfides. Figure out how much they weigh here. And when you pour the charge in there, the gold is the heaviest, so it goes to the bottom and all the slag floats on top, and we should get a little gold button at the bottom there. Okay, so there's our pour. Down into our cone mold. We'll let that cool off, and then we'll, there we go. We'll let that cool off, solidify, and then we'll knock it out of the cone mold and see what we got. Okay, it's cooled off pretty well, real glassy. You might be able to see the shatter marks in it. Oh, there you go. From it cooling down. As it cools down, it tends to break up like that. So I'm gonna knock it out of the cone mold, put it in this steel tub here, and we'll see what we got. All right, there it is. There's our little button. I'll see if I can knock some of this slag off.
Let us summarize.
Definition: elements are made up of only one type of atom, while compound is made up of two or more elements that chemically combine, and mixture is made up of two or more substances that physically combine. Representation: elements are represented by symbols. Compound is represented by a formula which contains symbols of elements that combine, example H2O, and mixture has no definite proportion. Ability to be broken down. Elements cannot be broken down into simpler forms. Compound can be separated into simpler forms by chemical method, and mixture can be separated into simpler forms by physical method. According to type, there are 118 elements classified into metal, non-metal, and metalloids. And there are lots of chemical compounds exist on Earth. They are classified into ionic, covalent, and intermetallic. And the mixture are classified into homogeneous and heterogeneous. According to boiling point, since element and compound are pure substances, their boiling point increase then become constant, and mixture keeps on changing at different times. Melting point: both element and compound melt easily and completely, meaning they have narrow range of melting point, while mixture does not melt completely, meaning it has wide range of melting point. For example, for elements we have hydrogen, oxygen, and sulfur. For compound we have sodium chloride and sodium bicarbonate. And for the mixture we have salt or sugar dissolved in water. That's all, class. Goodbye. Have a nice day!